Boys and girls, this is Mr. Manise here. Welcome to this video, and in this video I'm going to walk you through how to solve each of the problems in your circles packet for the test review. And my disclaimer as always, I really need you guys to not come to this video and just watch it, especially for this unit because this unit is so hard. I really need you guys to be working these problems on your own, working through the problems in your packet, and then coming to the video to see where you get stumped or where you might have made any mistakes. And as always, check your solutions online on the website. So my Clemson motif, here is my lovely little power bracelet that I wear. Clemson colors, orange, purple. A lot of people think orange is my favorite color because that's Clemson. Actually, it's not. My favorite color is purple. So there you go. So let's jump right on in here. So a lot of the stuff that you're going to see in this video is exactly like the problems that I went through in the quiz review video if you watched that one as well. But we're just going to double up here just to make sure you guys have a full understanding. And guys, when you walk into your classroom, whatever teacher you have, when you walk in that door for the test, you must know before you walk in what an interior angle is, how to do the wet problems, what an inscribed angle. Inscribed is half of the arc. Exterior is 1/2, big minus little. Wee is whole times exterior equals whole times exterior. You must know those concepts when you walk in. You're not going to be able to take time and sit there at your desk and wonder, now wait a minute, is this a PP problem? Is this a central angle problem? What kind of problem is this? You got to know that. So study your graphic organizer, study your packet. Look at that worksheet that I posted on my website where you can just practice identifying what kind of problem it is, okay? You don't even have to work it. Just look at it and say, okay, that's this kind of problem, that's this kind of problem. Here's the formula that applies to that problem, because that's half the battle right there. Okay, so let's jump right on here. Number one says find the measure of the arc or the central angle indicated. So they're asking for an angle here, so they want the measure of angle HGJ. Okay, so I like to color code these things. I'll color code these in red. Okay, so they want angle HGJ. Okay, so there's that angle. Do that in red, HGJ. In order to get that angle, I need this arc. Of course, we're talking about a central angle, okay, because the vertex of the angle is sitting there right there on the center, okay. So if that angle is 60 degrees, then this arc is 60 degrees, this arc is 67 degrees, so this angle is 67 degrees. So basically all I have to do, guys, I just have to add these together. This angle plus this angle equals the whole red angle. So 60 plus 67 is going to give me 127 degrees. Okay. All these problems, guys, where they're asking for angles and arcs, you've got all these different lines here inside the circle. This is your arc addition postulate where you're going to be adding arcs together. The other thing that you're going to have to keep in mind is, do I have a semicircle? In this case, I do. I've got a diameter. When you have a diameter, that's a red flag. Hey, maybe I'll use 180 degrees on that one. This one I don't have a diameter, so I know I'm not going to use 180 on this one. This one I might. Okay, so just keep that in mind. Number two, the measure of TW. Okay, so let's do this. Now this is an arc. This one was an angle. This was an arc. But remember, these are all central angles, so the arcs and the angles are all the same. Okay, so let's grab a green one here for the arc. TW. So they want this guy right here. I want the green arc. Okay. Well, I have a piece of it. I have 70. So that lets me know, I need TX. Okay, I'll put a little, well, I could put X there. Put a little X right there. I need that. Well, how am I going to get that? Well, this angle is 82, so that means this arc is 82. This is angle 70, so this arc is 70. That's 76, and that's 70. So when you get stumped on these problems, guys, and you don't know what to do, remember 180 degrees and 360 degrees is in your back pocket. So I can say, oh, wait a minute. This guy plus this guy plus this guy plus this guy, that makes up the whole circle except for the piece that I want. So really all I need to do is subtract these numbers from 360, or add them all up and subtract from 360, however you want to do it. So the answer is going to be 360 degrees minus each of these numbers, minus 70, minus the 76, minus the 70, minus the 82, and that comes out to be 62 degrees. Okay, so what I just found was the red piece. Okay, they're asking us for the whole green piece. So if the red piece is 62, then I just need to add the 62 plus the 70 to get the whole piece. So TW is going to be the 62 plus the 70. Add those together, and that comes out to be 132 degrees. Okay, check these guys. Go back and add up the 62, the 70, go back and add all these up, make sure they all equal 360. Don't turn your test into the box or into your teacher until you go back and check all these. Number 3, okay, they want an arc. I see the little arc symbol. JKH. So let's stick for the green. JKH. Now, if you're wondering, guys, how do I know which way to go? How did I know to go TW? How did I know to go this way and not go around this way? How did I know that? Well, you look at the letters. This is 2 letters. If it's 2 letters, then it is a minor arc. It's less than 180. So that tells me, oh, okay, this must be the smaller one. Down here, how many letters did they use? They used 3 letters. So that tells me, oh, this must be the long way. This is a major arc that's greater than 180. So J, K to H, okay, major. J to K all the way around to H. That lets me know it's a major arc. Okay, so I need the green. So how am I going to get the green? Well, I can get the red piece. This guy is 155, right? So that means this red piece is 155. Okay, and so now how am I going to get? I have the red piece. I have the kg. I have the 50. I still need this little kj piece because I can just add the 3 numbers to get the whole green arc. I don't have that little piece. So once again, how am I going to figure that out? Well, 180, no, I don't have any dimers, 360. So once again, I'm looking at, oh, okay, well, all of these numbers are everything, the full circle, except for this little piece. I'll do this in blue. Okay, so I can subtract all these red numbers from 360, and that will give me the little blue piece. So I can do 360 minus, let's just go around, minus the 50, minus the 155, minus the 70, minus the 54, and that comes out to be 31 degrees. Okay, so the blue piece, this little guy is 31 degrees. Okay, so to find the green arc, I'm going to add 31 plus the 50 plus the 155, and that gives me this whole green arc that I'm looking for. So JKH, the arc, is going to be equal to 31, the blue piece, plus the 50, plus the 155. And that comes out to be 236 degrees. Okay, number 4. This is another arc. JLI. Okay, that's 3 letters, so that's major. J to L all the way to I. Okay, J. And it doesn't matter that we're skipping K and M. That has no effect on the problem. You can skip letters. Okay, so I want this whole green arc. J to L all the way around to I. Okay, well, I know that from I to L is 180 degrees, right? That's a semicircle. Okay, so this piece, I could do this in red if I wanted to. Okay, so that piece in red is just a semicircle. And a lot of times, guys, there are multiple ways to do these kinds of problems. You can remember vertical angles or essentially vertical arcs. That's one way to do it. Alright, so the red piece is 180. So basically what that means is all I really need to find is KL in blue. Because if I found KL, I could just do 50 and the blue arc and the 180. I can add all those together. Okay. Alright, so to find the blue arc, I could say this is 180 degrees. Okay, this is a semicircle. So I can do, for the blue, I can do 180 minus, this is also 65. 180 minus the 65 minus the 50, and that gives me 65. Okay, so this piece is also 65. Alright, so then that gives me everything I need for the green piece. I can add the red piece plus the blue piece plus this 50. I can add all those together. 50 plus 65 plus 180. And I can say JLI is equal to 50 plus 65 plus the 180. And all that comes up to 295. Oops. Now some of you guys may be looking at this and going, wait a minute, Mr. Manise, wait a minute. Isn't there an easier way? Yes, there's an easier way. If you guys were smart, and I did this on purpose just like I did in the previous video, I want to show you there are multiple ways to get the right answer. If you guys were smart, putting on your thinking caps and say, wait a minute, this whole green arc is everything in the circle but this guy. So check this out. What if I just do 360 minus the 65? Guess what that gives me? Oh, that still gives me 295 degrees. Okay, so a lot of times, guys, there's an easy way to do this and there's a hard way to do this. It's up to you to see if you can figure out the shortcuts. Okay, just want to make sure you guys were clear on that. Multiple ways to get the same answer. Okay, let's move on. Number 5, find the length of the segment. Okay, so when you guys see the right angle on the test, you're going to know, okay, this is Pythagorean Theorem. All right, so our formula, our concept says if the chord makes a right angle with the radius, which it does, then the chord is bisected. So if that guy is 14.4, that guy is 14.4. And now I have my right triangle here. Here's my right triangle. And now it's just Pythagorean Theorem, a squared plus b squared equals c squared. Now in this case, we're trying to find the hypotenuse of the right triangle. So when you're trying to find the hypotenuse, you square both of these numbers and add them together. So a squared plus b squared equals c squared, in this case x squared. If you type all that into calculator, x squared is equal to 248.32. Nobody cares what x squared is. I want x, so you take the square root. And x is equal to 15.8. This is round to the nearest tenth. 15.8. Okay. Okay, that's it for that one. And let's go over here to this one, number 6. And I see a right angle, so that's also telling me Pythagorean Theorem. Now here, notice guys that this 27 is sitting on the center. Okay, the 27 is not over here, it's not over here. When it's in the center, you got to divide that by 2 to find the actual radius, which in this case is 13.5. So this little piece right here is also 13.5. The chord is making a 9-degree angle with the radius, so if that's 11.2, tick tick, and that's 11.2. Okay, so what I'm trying to find, guys, temporarily I'm trying to find this blue piece. Okay, I'm going to call that, they want us to find x. Let's do this in, I'll do this in orange. They want us to find x, but before I find x, I've got to find this blue piece. I'm going to call this y. Okay, I'm not going to call it x because the orange piece and the blue piece are not the same length. So the first thing I need to do is find y using Pythagorean Theorem. I'm trying to find a leg. Okay, so it's, you still square both numbers, but instead of adding them together like you would to find the hypotenuse, you subtract them. So I'm going to do the big number squared, 13.5 squared minus the 11.2 squared. That's going to equal y squared. Type this into my calculator. Y squared is equal to 56.81. Nobody cares what y squared is. I want y. And y is going to be equal to 7.5. So what I just found was the blue piece, which is 7.5. Okay, but I still need the yellow. I still need the orange piece. Well, what do you notice about the blue piece and the orange piece? What does that form? This whole straight line here in green. Isn't that just a radius? Isn't that just the same thing as this guy? So if that's 13.5, then this whole green piece is 13.5. So to get my answer, what I have to do is I have to do the whole radius, this whole length, which is 13.5, and then I have to subtract out the little blue piece that I found, which using Pythagorean Theorem we saw was, I'll keep it in green, is the 7.5. And when you subtract those, you get your final answer, which is 6.0 technically, for rounded to the nearest tenth. Okay, so let me go over that one more time. Divide the radius by 2, that gives you the hypotenuse, that gives you this piece. Use Pythagorean Theorem to find this leg. Okay, you do the big number squared minus the little number squared, and then take the square root of that, that gives you the leg. If you don't like that, then go ahead and set up your equation. A squared plus b squared equals c squared and solve it like normal. I'm just showing you the little shortcut. Once I get the blue piece, I have to subtract that from the regular radius to get this small orange piece, which is x. Okay, well, let's go ahead and flip on over. Okay, now we're talking about angles here, more angles. All right, where do you notice in all these problems, guys, with all these different formulas, this was the day where we talked about inscribed angle, exterior angle. This is by far, in my opinion, the hardest lesson in the whole unit because it's so difficult to remember what kind of angles they are. And is this the 1/2 big minus little? Is this 1/2 the sum of the arcs? What is this? The easiest way I can tell you to remember is find the vertex of the angle. Angle, 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 angle. Look down here. Angle, angle, okay? Find where the vertex is. And this problem number 7, and when I say vertex, if I have an angle, that guy right there, the bottom of the V, okay, the corner of the angle is the vertex, okay? So let me do the angles in red. So here's the angle right here, the question mark. That's what we're trying to find. So there's my angle. I would encourage you guys, like I said on the last video, bring your colored pencils, crayons, markers, whatever. Grab some from home, color code these guys. So I'm trying to find this angle. Okay, where is the vertex physically located? There's the bottom, there's the corner of my angle. It is sitting on the circle. Okay, when it's on the circle, that's an inscribed angle. Okay, vertex, I'll put vertex on the circle. And that's going to apply to all 4 of these problems. Vertex on the circle. Vertex on the circle. Vertex on the circle. So in the inscribed angle, the angle is half of the arc. Okay, which arc are we talking about? Here's where you got to find the snow cone. Here's the cone, like I got an ice cream cone. There's the cone in red. Here's the ice cream. I'll do in green. Mint chocolate chip, green. A Christmas cone, okay? So this angle is intercepting this arc right here, the snow cone. So if I had the green arc, I would be able to find the angle by doing what? This is half of this. Okay, so if I found the green arc, I would just divide by 2. If you can't remember whether to multiply by 2 or divide by 2, think about it this way. This angle is increasing. It's getting bigger and bigger and bigger, right? Okay, angle's getting bigger and bigger. It's getting wider and wider. So kind of think about, doesn't it make sense that this angle would be smaller? This number would be smaller than this one since my angle is kind of widening here. So that will help you remember this number's got to be bigger than this number. Okay. So if I had the green part, then I would divide by 2 to get the angle. Well, I don't have the green part. Okay. So once again, I'm thinking, can I use 180? Can I use 360? I can't use 180 here, and this is a mistake that I've seen students make. They're trying to draw in diameters here. They're trying to draw a line through this dot. You can't assume that, guys. You can't assume that something like this, you can't assume that this is a diameter. You can't draw that in there. We can't make that assumption. So that tells me, hey, maybe I need to use 360. Well, I can do that because I've got this number, the 158, that's this arc, and then I have the 100, which is this arc, Vx. So can't I just add those numbers and subtract from 360 and get the green arc? Yes, Mr. Maniz, you can. Okay, so let's add those together, subtract from 360. So I'll say that arc WV, which is what we're trying to find, is going to be equal to 360 minus the 158 minus the 100. And that comes out to be 102. Okay, but that's not what we want. All we did was we found the green part. Okay, so the angle that I'm trying to find, so I'll say angle WXV is going to be equal to 1/2 of that number, half of the arc. And I'll draw this just so you guys can see. This is 102. Alright, so I just divide that by 2 to get my angle, and that's going to be equal to half of 102 is 51 degrees. Okay, inscribed angle on the circle, half of the arc. Inscribed, half the arc. Okay, number 8, where is the vertex? Again, it's on the circle. So here's my snow cone. Angle, there's my snow cone. Where's the ice cream? Here's the ice cream. There's the top of the snow cone. Okay, so once again, if I had the green piece, then I can divide by 2 to get the angle. I don't have the green piece. I also can't use 360 because, yes, I have the 206, but I don't have that piece. I can't just add these and subtract. So how can I get GE? Well, that tells me I'm going to have to use this number, 37. So this angle that I'll do in blue, this guy, where's that vertex? Guess what? It's on the circle. So that's going to intercept this. I guess I should do this maybe in black. That's going to intercept this arc. So if the blue angle is 37, how do I get the black arc? I just multiply by 2. Remember, our angle is getting wider, so that number is getting bigger. So multiply 37 times 2, and that gives me 74. And now I have what I need. I've got the 74 and the 206. I can subtract both of those from 360, and that gives me the green piece. Okay, so I can say arc EF is 360 minus the 74 minus the 206. And that gives me 80 degrees. Okay, so the green arc is 80. And now I'm ready to find my original problem, which is the angle here, the red angle, the inscribed angle. And so I can say angle FGE is equal to half of the arc, which is 40 degrees. So this guy is 40. See how the number is getting bigger? Angle is smaller than this outside arc. Okay, number 9. Okay, so here's my angle. The question mark is right in between these two lines. So it's between line segment XH and line segment HY. Okay. Vertex, where is it? It's on the circle, so it's inscribed. All right, here's my snow cone. Snow cone. There's the ice cream. So if I had, once again, if I had the green piece, I could divide by 2 to get the question mark. Okay, well, can I use 360? Not really, because I don't really have any other outside numbers to set the 66. That tells me, wait a minute, I have a diameter. This is the only one of these 4 problems that actually has a diameter. No diameter, no, no. But this line goes through the center, so that ought to be a big blinking red flag. Hey, 180 degrees, semicircle. So if I do this in orange, the whole orange thing, arc, is 180 degrees. So can't I just say that arc semicircle XHV is 180 degrees? So if I do 180 degrees minus that guy, minus 66, that is going to give me 114. Okay, so the green arc is 114. Everybody see that? 66 plus the 114 forms this orange semicircle. Now I have the green arc. What do I do to get my angle? I divide by 2. So angle HXV is going to be half of 114, and that is 57 degrees. Okay, last one. Where's the vertex? It's on the circle, so that's the inscribed angle. So here is the angle. I always draw this out, guys. I'm the geometry teacher. I've been doing this for years. I still do it this way because it helps my brain to focus on what I need. Okay, here's the arc. There's the snow cone. So where's the ice cream? Here comes the ice cream. Here's the rest of my snow cone. Okay, so just like all these, if I had the green arc, I could divide by 2 to get the angle. I don't have that. I have a piece of it. I have the 92, but I'm still missing this piece over here, which I will do in purple. I need SR. If I had SR, then I could add the SR plus the 92 and get the green. I don't have that. So that tells me, well, what else can I use? I don't have this piece either. So this is going to be a little bit complicated. So that tells me I'm probably going to have to use this 106 degree inscribed angle. I'll do this one in black. So the 106 angle, here's the snow cone for the 106. Vertex is on the circle. That's going to intercept this black arc, this whole thing. Okay, does everybody see that? I turned this upside down. You can see that. Here's the black snow cone, and here's the black ice cream for that one. So if this guy is 106, how do I get the black arc? I'm going to double it. So 106 times 2 is 212. So this whole black arc is 212. Okay. Well, if the whole black arc is 212 and the green piece is 92, I could subtract 92 from 212, and that will give me NQ, which I will do in orange. Try not to overlap these colors. Okay, so if I do 212 minus the 92, I know this is a little bit confusing, guys, just hang with me. The black arc minus the 92 gives me 120. So the orange piece is 120. Okay. All right, so now I think I have everything that I need. I have the 92, I have the orange piece, which is 120, I have this piece, which is 88. Now I can subtract all of those from 360. So I do 360 minus the 92 minus the 120 minus the 88, and that actually gives me 60. So this purple piece is 60. You actually didn't have to break down this orange, guys. You could have just used the whole black arc. You could have just said the black arc plus the 88 and subtract both of those from 360 is just another way to do it. Probably a little bit quicker to do it that way, actually. But we still get the same answer. The purple arc is 60. Okay, but I got to go back. I got to go back and find this whole green arc. Okay, how do I find the green arc? I need the 92 plus the missing piece 60. So the green arc is going to be 60 plus 92, which is 152. Okay, so if the green arc is 152, how do I get the red angle? I'm going to divide by 2. So I will say the angle NQR is equal to 1/2 of 152, which actually comes out to be 76 degrees. Not going to lie, guys. Not going to lie. That was tough. That was tough. That would be like a, maybe a bonus type problem on the test. Pretty difficult. Go back and rewatch that one again if you didn't follow that. Okay, number 11. Do you see a degree anywhere? Yes. So we're still talking about angles. A lot of students look at this and say, oh, that's the PP problem. That's the part times the part. No, I got degrees here. So we're still in angle land. Okay, so where is my angle? There's my angle, 76 degrees. Where is the vertex? Okay, it's inside the circle. So when the vertex is inside the circle, this is interior angle. Interior, okay. So what is the relationship with interior? That's equal to 1/2 the sum of the two intercepted arcs. Okay, so that is going to be 1/2 of the snow cone over here and the snow cone over here. Now, it would be nice if the variable is in the middle and they gave us the two arcs. That would be easy. I would just add that arc plus that arc and divide by 2. They're not so nice to us this time, so we actually do need to set up an equation. I'm going to say my angle in all these angle problems, guys, the angle is always on the left. Angle is equal to 1/2 the arc. Angle is equal to 1/2 the sum of the arcs. So my angle, which goes on the left, is equal to 1/2 of, parentheses, the sum of the two angles. There's a question mark, I'll just use an X. That guy plus that guy, X plus 89. Okay, now there's no need to distribute. I could just multiply both sides of the equation by 2. 1/2 of 2 is 1, that's why we do that, so those guys cancel. 2 times 76 is 152. So on the left I have 152, and on the right I'm just left with the X plus 89. Subtract 89 from both sides, they cancel, and X is equal to 63 degrees. Interior angle, 1/2 the sum of the arcs. In other words, this guy is going to be the average of these two numbers. If you use the little trick that I taught you in class, the other way to do this quicker, mental math, is to say, well, 76 is how far away from 89? It's 13 away, right? So 76 is less than 13 less than 89. So if 89 is 13 away on the high side, to figure out what's on the low side, I will subtract 13. Well, what's 76 minus 13? Guess what? It's 63. Okay. 76 is halfway between 63 and 89. When you add two things together and divide by 2, you just found the average. So the interior angle is the average of these two guys. So go back and check and make sure that when you add 63 plus 89 divided by 2, you do actually get this interior inside angle. Go check your work. Check, check, check. Number 12, angle. Where's the angle physically located? Outside the circle. So this is exterior land. Exterior angle, outside. And that is going to be equal to 1/2 the difference of the two arcs, or the way I like to think about it is big minus little. It's going to be 1/2 of this big arc minus this little arc. In this case, they were nice to us. Okay, the variable actually is the angle, which makes it nice. My angle x is equal to 1/2 of the big arc, the one furthest away, minus the little arc. So I just plug that into my calculator. 175 minus 99 is 76. Half of 76 is equal to 38 degrees. 1/2 of big minus little. If the variable had been one of the arcs, then your angle would have been a number. Just like over here, the angle was the number. So in this, if the variable say we're on the outside here, then it would be number equals 1/2 parentheses x minus the little one. And then you would need to multiply both sides by 2. 1/2 would cancel, and then go on to solve from there. Okay. All right. Do you see a degree symbol down here? No. So we're not talking about angles. We're talking about line segments. Okay, lines. All right. So this is the PP problem. You got part times part equals part times part. Okay. So I can say this piece x, this piece times this piece, x times 12, or 12x, is equal to this piece, 15, times this piece, times 8. I can color code those for you guys real quick. 8 red times green is going to be equal to purple times orange. Okay. So multiply this together in your calculator. 12x is going to be equal to, that is 15 times 8 is 120. And then you're going to divide both sides by 12. And you get x is equal to 10. Make sure I can see that. X is equal to 10. Go back and check. Plug it back in. Does 10 times 12 equal the same thing as 8 times 5? Yes, it does. So check your work. Okay, 14. This is the wee-wee problem. Whole times exterior equals whole times exterior. Okay, so the outside piece. I can color code these. 7 in red. The whole piece is in purple. You got to remember to add the x plus the 7. Okay, the whole purple piece, and I got this outside red piece. Trying to make sure y'all can see it on the video. And then I got this outside green piece, and then I have this inside blue piece. Once again, you got to remember to add these together. Okay, whole times exterior equals whole times exterior. All right, this is the PP problem. Part times part equals part times part. Okay, whole times exterior. I always like to start with the exterior first. Camera's back in focus. There we go. I always like to start with the outside piece first. So I'll do 7 times, what is the whole piece? You got to add, it is not 7x. You got to add the 7 plus the x. Think about a piece of string. If this is a piece of string of length of 7, this is a piece of string of length of x, the whole piece of string is x plus 7. That's going to equal this outside green piece, 8, times the whole piece, which is 6 plus 8. Okay, you got to use the distributive property here. 7 times x is 7x. 7 times 7 is 49. And that's going to be equal to 6 plus 8 is 14, times 8 is 112. Let's subtract 49 from both sides. 7x is equal to 63. Divide both sides by 7. And x is equal to 9. pure coincidence, guys, that it's 6, 6, 7, 8, 9. Okay, don't fall for that trap. Okay, all right, so that's it for that side. Let's move on over. Ooh, yes, quadratics. Gotta have some quadratics. Quadratics are fun. I know you guys may not like them, but it's very good critical thinking type of problem. Lots of steps. Okay, so this is, what kind of problem is this? This is a wet problem. Hole times exterior equals tangent squared. How do I know it's, how do you know the difference between wet and wee-wee? Well, this line, this outside line, only touches the circle in one spot. So that's a tangent line. And then I still have the hole times exterior. I got this outside piece, the 9, and then I got the whole piece here in green. You got to add the 9 plus the 16. Okay, so let's start over here. The exterior piece, 9, times the whole piece, which is 9 plus 16, add them together, is equal to the tangent squared, which in this case is just x squared. 9 plus 16, flip on over. 9 plus 16 times 9 actually comes out to be 225. So x squared is 225. Nobody cares what x squared is, we want x. So you got to take the square root. X is equal to 15. Okay, that's your wet problem. Hole times exterior equals tangent squared. Technically, this is a quadratic, guys, but when on the wet problems, it will always be the square root method. You won't have a full trinomial that you'll have to factor, because you'll just have an x squared on one side and you'll just have numbers on the other side, so you'll just end up taking the square root. Now on this one, now notice the x is on the outside. Now this one, the x is also on the outside. So guys, when you see that x on the outside, I already know it's going to be a quadratic, because I'm going to end up multiplying an x times another x at some point. Alright, so you got the x piece, and then you got the whole green piece, and then you have this 6 blue piece, and the whole orange piece. Okay, so it doesn't matter where we start. Let's start on the left. The outside piece, the purple piece, x times the whole piece, you got to add those together. That's x plus 7. Add them together. Is going to be equal to this outside blue piece, 6, times the whole piece, 4 plus 6. Distribute. X times x, there we go, there's our quadratic. X times x is x squared, plus x times 7 is 7x. 4 plus 6 is 10, 10 times 6 is 60. Alright, I need my quadratic set equal to 0, so let's move the 60 to the other side. X squared plus 7x minus 60 equals 0. Alright, now that's our classic standard form. Ax squared plus bx plus c equals 0. So now I'm looking to see, can I factor this? Are there any factors of 60 that will add to 7? Okay, guys, if you can't remember how to do this, if they're kind of larger numbers, here's the little trick. You can go press y equals, type in the number you're trying to find factors of, 60, and press divided by the x button right here where my finger is, divided by x. And then go second, and go table right here, second table. And so now you're looking at these combinations. These are the numbers that multiply to give you 60. So you're looking at these combinations. Which combination of those numbers will add to give me 7? Okay. So in other words, which of these two numbers are 7 apart from each other? 1 and 60, no. 2 and 30, no. 3 and 20, no. 4 and 50, no. There we go. 5 and 12. Those are 7 apart from each other. But since this back term is negative, that means one of them has to be positive, one of them has to be negative. And the sign of the middle term will determine the sign of the bigger one. So that means it's going to be a positive 12 and a negative 5. So this quadratic simply factors as x plus 12 times x and then minus 5. When you factor a quadratic, guys, in the ax squared bx plus c term standard form, you're going to get two binomials unless it's a perfect one of our special cases, which in this case is not. So go ahead and write down your two. I always go ahead and like to write down my two sets of parentheses. And with your two factors, just go in the parentheses with the x. So if it's plus 12, it's x plus 12. Negative 5 is x minus 5. Then the last step is to do what with the signs? Flippy flip. Flip those signs. So you get negative 12 and a positive 5. Well, we're not done. We're talking about lengths here. So I've got to go back. Obviously, if I plug in a negative 12, I can't have a negative length. So the only answer that works is positive 5. Okay. Once again, guys, don't fall into this trap of 4, 5, 6, 7. Okay, don't do that. Okay. Quadratics. Go back and watch those a couple times if you're a little weak on quadratics. Okay, number 17 is our perimeter problem. I love these problems, like little puzzles that you're trying to put together. So I can color code these. These are all tangents. So this red line is tangent. This red line is also tangent. And we know that two lines that form a tangent to the same circle are going to be equal to each other. So I can put a tick there and a tick there. These two green lines are also tangents, double tick. Green line, double tick. And let's go blue. This line and this line will be the same. Triple tick, triple tick. That shows up on the video. Zoom. Come on, you can do it. You can do it. There you go. Okay, so if this red piece is 7, then this red piece is 7. If this red piece is 7, to get the green piece, I would just subtract 7 from 15, which means this green piece is 8. And if that green piece is 8, this green piece is 8. And if this red piece is 7, I need to subtract that from the 10.6, and that will give me the little blue piece, which is 3.6. If that is 3.6, then this little blue piece has to be 3.6. And now to find the perimeter, I just need to add up all these little numbers. Or you don't have to add these two, you could just use the whole 10.6 if you want, but I'll just add up all the little numbers. Perimeter is going to be equal to 8 plus 7 plus another 7 plus a 3.6 plus another 3.6 plus that last 8. And that comes out to be 37.2 for your perimeter. Okay. Home stretch here, guys. You can do it. All right. Find the arc length and find the area of the sector. Guys, I know 2018, I know your packet says this. I'm going to scratch this out. I'm not going to do any of that. We're not going to leave our answers in terms of pi. I need to get back and change this. We're just going to do everything in decimals. That's the real world, guys. Nobody leaves anything in terms of pi in the real world. Nobody. Accountants, engineers, lawyers, nobody. So let's just round everything to the nearest tenth. Okay, so arc length. Okay, so this, you got to know your formulas. N over 360. It's always going to be n over 360, but now we're talking about length. So we're going to take the percentage of the circle that we're talking about, n over 360, and we're going to multiply that times the whole circumference of the circle, which is 2 pi r. Okay, so my angle in this case is 210 over 360 times 2 times pi times my radius, which is 17. And to plug that into my calculator, I'll just show you how to do that real quick. Second quit. All right, let's go. 210 divided by 360 times 2. I don't even need to press times. Pi. I don't even need to press times here. I can just do 2 pi 17. And that gives me 62.3. 62.3 is the length. Okay. All right, next one, same thing. Still arc length, so it's going to be my angle over 360 times 2 pi r, 2 pi times 18. Punch all that into your calculator. 30 over 360 times 2 pi 18. I get 9.4. These are easy. I know you guys probably wish the whole test were like this. Just plug and chug, baby. Just plug in the numbers and chug it in your calculator. All right, now this is area of the sectors. We're not talking about, these are pizza crust of the Papa John's pizza, right? Just the outside edge, circumference. Now we want area. We want all of this, the whole piece of pizza. So this is still going to be n over 360, but now it's not times the circumference of the circle. It's going to be my percentage that we're talking about times the area of the circle. Area of a circle is just pi r squared. Okay, so my angle is 60 degrees. 60 over 360, so that's basically 1/6. 60 over 360. We're talking about 1/6 of the pizza. So 1/6 of the whole circle, which is pi times r squared, which is 6 squared. Punch all that in my calculator. 60 divided by 360 times pi squared. I get 18.8. Okay. Technically, we should keep up with the units here. This is kilometers. Arc length is just one dimension, so it's just kilometers. Here, we're talking about feet, so really this should be feet squared. We're talking about area, length times width, feet squared. All right, 21 here is another area of a sector. So once again, it's n over 360 times pi r squared. Okay, so my angle is 315. We're talking about most of the circle here. I just want to do this real quick just so you guys can see. I did this in class for my students, but if you don't have me, 315 over 360 is 8.875, which is 88%. So we're talking about 88% of the circle. So if I want the darkened area, wouldn't it make sense that I would take 88% of the area of the whole circle? And that's what we're doing. We're taking 88% of pi times r squared. So I'm taking this percentage. I can just type it in, 0.875, that percentage times pi times 10 squared, which is the same thing as 315 divided by 360 times pi times r squared. Same exact thing, 274.9. I just really, and this is going to be centimeters squared. I just really want you guys to understand that all these arc length and area sector problems, this whole n over 360 business is just what percentage of the pizza are we talking about? Are we talking about a fourth of the pizza? We're talking about half the pizza? We're talking about 88%, 22%? And then I take that percentage times the full circumference or times the full area to get the little piece that I want. Okay, 22 is difficult, flat out difficult. Once you see it, you'll be like, oh man, I should have known that. Once you look at it, it's like, holy cow, what do I do? Draw a picture. Find the distance. There you go. There's that trigger word, distance. So it's not area. Okay, we're not talking about area. We're talking about a distance, the length, physical distance. Find the distance that the Earth travels in 1 month in its path around the sun. Okay, sun, path around the sun. Here's Earth. And they want the distance that it travels in 1 month. Well, how many months does it take to go around the sun? A year, 12, right? We just want to know how long does it take to go in 1 month. So aren't we just talking about 1/12 of the pizza? Or in this case, we're talking about 1/12 of the orbit around the sun. We're talking about 1 month out of 12 months. So once again, that's our n over 360. 1 divided by 12, we're talking about 8% of the year, 1/12 of the year. So if I want to find the distance, doesn't it make sense that I would take 8% of the whole circumference? Why, yes, Mr. Maniz, that makes perfect sense. Okay, so my path is going to be 1/12. Now, if you want to get an actual central angle, if you want this angle, you can absolutely find that. Okay, you could do, on my calculator, I could do 360 divided by 12, okay, and that gives me 30 degrees. So that means each one of these little angles for every month around the sun, each one of these central angles is 30 degrees. 30 degrees, 30 degrees, 30 degrees. Okay, so that's one way you could do it. Okay, so if you type in 30 degrees n over 360, if I type that in, 30 divided by 360, guess what? That's the same thing as 1 divided by 12. It's still 8% of the circle, okay? So I'm just going to use 1/12 after my camera comes back into focus. 1/12 of the whole circumference, which is pi, excuse me, is pi d. What did they give us? They gave us radius. It's either pi d or 2 pi r, whichever one you want. We'll use 2 pi times the radius, which is 93 million. Okay, fine. So I'm just going to take this 1/12, or you can do 30 over 360, that's fine, that's 1/12, times 2 times pi times 93, 1, 2, 3, 1, 2, 3. That gives me that huge number. Comma there, that's 48 million. So this is going to be equal to 48 million 694,680. I'm just going to round this to the nearest whole number. It's silly to put a decimal there. So the path after 1 month is going to be 48 million miles. And if you multiply that times 12, that'll be the full path all the way around the circle. And this is miles, of course. Okay, so the hard part was getting the 1/12 and getting each of these central angles. Okay, last couple of problems here. This is the hardest problem you ever done in your life. Find the area. Area of a circle, pi r squared. Pi times 8 squared. And pi times 8 squared is 201.1. This is area, so that's going to be yards squared. And this one is, they give me their circumference, and they ask me to find the diameter, the radius, and the length of an arc of 45 degrees. Okay, I'm going to go ahead and plug this in. I know everything's in terms of pi. It's kind of up to you guys if you want to leave it as pi. I guess I'll leave it as pi this time. It doesn't really matter. All right, so the circumference, if you remember, circumference is defined as pi d, or circumference is equal to 2 pi r. So this time they gave me the circumference. Usually that's what I'm trying to find. So now I got to go backwards. So if I want the diameter, wouldn't I just divide both sides by pi? And diameter is going to be equal to circumference over pi, which in this case the circumference is 16 pi. And this is why I left it in terms of pi, because when you leave it that way, the pi's cancel. So your diameter actually is 16 in this case. They asked for the radius. Of course, the radius is half of that, which is 8. And then they asked for a length of an arc of 45 degrees. Arc length. Okay, so that's going to be my angle over 360 times 2 times pi times the radius, which we just found was 8. And if you type all that in your calculator, 45 divided by 360 times 2 times pi times 8, that actually gives me 6.3. If you wanted to leave it in terms of pi, you just wouldn't type in pi in your calculator. It would just be 45 over 360 times 2 times 8. But I prefer to put things in decimal form because that's the real world stuff. Guys, I've been telling you guys all unit, you have no shot at this test of making the grade that you want unless you study this stuff over and over and over. Study your graphic organizer. Go back and watch this video 2 times if you need to tonight. Okay? Work these problems out. Study the sheet. Know your formulas. Know that an exterior angle is 1/2 big minus little. Know what an inscribed angle is. Know where the vertex is and be able to immediately figure out what kind of problem it is when you look at that problem on the test. Okay? Hope you guys enjoy this video, and I wish you the very best of luck on your test, and we will see you on the next video.